Hello, everyone. My name is Howard Zisser. I'm the Director of Clinical Research. I know you guys got it. Here in Santa Barbara at Sansom Diabetes Research. And I spend my days as a physician, as a researcher, but also as a designer of technology. And what I'm going to talk about is how we learn to trust technology, whether we should trust technology, and what that process is about. Alfred North Whitehead was a mathematician, and he wisely said, "Civilization advances by extending the number of important operations which we can perform without thinking of them." And if that's his definition, if that's true, we live in a very advanced society. Everything is getting faster and faster, more automated. And sometimes this works out, sometimes it doesn't. People tend to fall in one of two camps. People that are very trusting, very open, and also people that are not so trusting. They trust nothing, don't believe in anything. Technology is often defined as what has been invented after we were born. I'm just going to step back in time a little bit to talk about how some of technology became usable and trustable. This is Elijah Otis. He did not invent the elevator. He invented the brakes to the elevator. And he did a demonstration in New York in 1854 demonstrating this. He built an elevator, cut the rope, and he did not plunge to his death. Prior to that, this was a risky endeavor. Unfortunately for Elijah, he passed away 6 years later of diphtheria and poverty. But we know that his business lived on and has changed the face of architecture and building structures around the world. But elevators continue to evolve. Technology continues to evolve, but we still have an issue with trust. This is a design for a modern elevator called the smart elevator. And when you walk up to the elevator, instead of hitting the up button or the down button, you just say, "I want to go to floor 13. It's odd that they chose unlucky 13, but they did in this picture. And for efficiency purposes, it groups you with people that are going to floor 13. So it just tells you what elevator to go into, and it will take you there. The problem is, when people get into those elevators, there's no buttons anymore. So there's no control. So people feel loss of control and loss of trust. The aviation industry. This is a picture of the first fatality. This was Orville Wright was in the plane. He did not die. He was hurt. This is September of 1908. Thomas Selfridge, an Army officer, was in the plane, and he was the first, unfortunately, the first fatality in aviation. And this hasn't really changed, or it didn't change until Lucky Lindy flew across the Pacific. Landed in Paris. He actually landed at night, so there's not a picture of his landing. It was about a week later. And these technologies tend to evolve. And I think that's something we need to learn, is that technology is not static. If you're an early adopter of technology, you need to know what you're getting yourself into. You need to know what the risks are. But as it's used more and more, there's more failures, and then there's more mitigation of those failures. Now we have Autopilot and Fly-by-Wire. So the airplane on the left there is actually controlled completely by computer operation. So there's no physical connection between what the pilot's doing and what the instruments are doing. I'll just show a couple more examples, and I'll talk about some of the research I'm doing here in town. This is an example of Google cars. So this is not Britain. He's not sitting in the right-hand side. These cars are licensed to drive in both Nevada and California, and they operate primarily by following the instructions in Google Maps. To date, there have been 2 accidents. One has been when one of the drivers was driving the car, so it was not under automatic mode. And the other one was actually when somebody rear-ended one of the Google cars. So they have a flawless track record. They've logged hundreds of thousands, if not millions of miles by now. And the idea behind this, and it's not perfect, is to make transportation safer, more efficient, both on energy side and to avoid traffic collisions. Unfortunately, some of this technology is not perfect yet. So this is a bug in Apple Maps that came out a couple months ago. And I think it would be very difficult for any of us, including the Google car, to navigate these these pathways. So again, exciting technology, automation, but it's not perfect. But when we find these flaws, we can go back and make them better and make them more trustable. This is a fatigue detection. It's been under development for a number of years. And it basically, while you're driving, follows your eye movements, your head movements, and your driving characteristics. And if it thinks you're falling asleep, it tries to wake you up and avoid the crash. And this is my personal testimonial. This was 1 week ago. I was driving home from LA. It was midnight, as you can see. I was near Summerlin, and I was feeling a little tired. And my car woke me up to say, hey, you're a little tired. Now, I don't think the message here is great just to, go have a cup of coffee, you'll be fine. But I did the next logical thing. I grabbed my camera and took a picture going 70 miles an hour down 101 because I knew I had this talk coming up. So really, this technology is operating in the background. I don't have to turn any switches on other than start the car. And this stuff does save lives. It's not perfect, and will continue to evolve. Just briefly, my talk was really about technology and sustaining life, but our lifestyles are part of that life as well. And this is an example of the flash crash that happened about 2 years ago. I was just in Maryland at a medical conference last week and talked to one of the stockbrokers about this. And apparently what happened is instead of someone entering the dollar amount, I think they wanted to sell 5 million shares of something, they entered 5 million shares instead of $5 million. These automatic algorithms that are built into trading now not only follow the price of stocks, but they follow the volume of stocks. So someone saw that someone was getting rid of everything and then some. And what I find interesting is they all seem to be following the same rules. So within about 10 minutes, the stock market lost almost 10% of its value. Quickly rebounded, and they're working on fixes to prevent these types of anomalies. Technology often fails. We were here yesterday doing rehearsals, and there's always glitches that you think, how could that happen? It's just plug things in, it should work. These are some pictures from 2 weeks ago after Sandy. And the most important commodity seemed to be power so we can charge our devices. So it brought these people together, but what I like about this picture is the fact that everybody is closely grouped, but yet they all seem to be isolated from each other. They all seem to be right here in the palm of their own hands. Another idea that comes about when technology fails is reversion to previous technology. So the title of this picture is Not 1995, which I think is great. I don't think if somebody asked me on State Street today where a payphone was, whether I could tell them where that is. Failure of technology also sometimes causes innovation. When we are designing technology, especially things that are life-saving, what we like to do is build in redundancy to the system. So this is a picture, probably 1958, from Minnesota. And this is a pediatric patient. There was a pediatric hospital there. They did a lot of surgery for pediatric patients that had congenital heart disease. They had 2 separate electric companies supplying power to the hospital. So they thought, we're good, we're going to be fine. These pacemakers were actually plugged into the wall. After surgery, the patients would be paced until they were safe to go home. On Halloween of 1957, they lost power to both power plants. And they ended up losing a patient that night. That failure of technology actually got the innovators fired up to actually innovate and create the pacemaker as we know it today. Next, I'm going to talk about what I do in my everyday life. I work at Sansom Diabetes Research here in town, and I work mainly with patients with type 1 diabetes. Type 1 diabetes is an autoimmune disease that affects the cells in the pancreas that make insulin. Without insulin, we can't use sugar as a fuel. And as you can see, this is actually a picture of the same patient before and after treatment with insulin in 1922. These patients can't use glucose, they burn fat, they slip into a coma. And before 1922, this was a universally fatal disease. Banting and Best in Toronto figured out the issue, figured out how to purify and give insulin. And this is the same patient separated by about 4 months. This is William Sansom. This is the institute that I work at. He was actually the first United States physician to purify and give insulin here in Santa Barbara in 1922. And at one time during that year, the only place that you can get insulin in the world was right here in Santa Barbara. Now, they changed a universally fatal disease into a manageable disease. It wasn't a cure. It wasn't like, take this pill, you'll be fine for the rest of your life. You need to learn how to dose and manage your insulin. They also found that several years later, if you didn't control the blood sugar, you got complications. And these complications primarily occur in the vasculature, so in the arteries and the veins in the body. Fortunately or unfortunately, those veins and arteries go everywhere in the body, so you can end up with complications almost everywhere in the body. So what we're trying to do, and how I'm interfacing with technology and trying to make it trustable, is actually make an artificial pancreas to automatically dose insulin for patients with type 1 diabetes. This is a tracing, and I'll just quickly say that this is the glucose tracing. There's a wire that can go under the skin, which we helped get to market, which is now available. And ideally, your blood sugar will be around 90 or 100 all the time. So this gentleman, this was a grad student at UCSB that we work with, does not have type 1 diabetes. So there's pretzels, beer, all kinds of stuff in there. And his glucose, you can't get his glucose to budge at all. Unfortunately, this is how we see patients when they come to us. So there's a patient, she had the latest technology, she had a sensor, she had a pump, but no one really trained her how to use the technology. They just put it on her and assumed that she would know what to do. So here is a glucose value of 400, which over time will be associated with bad complications, and a blood sugar close to 40, which is associated with confusion, seizures, and coma. This patient does have diabetes. This is Matt. He's an engineer type, so very meticulous. And you can see he can almost flatline his glucose. We don't like to use the word flatline in medicine too often, but here it is. This is Matt. It takes a lot of work to do this. He's very dedicated. He's been in clinical trials for 20, 25 years, always wants to know what the latest and greatest stuff is. Each one of these points is a fingerstick reading. And overnight, no one is really watching the shop. So this is what we're trying to do, is design a brain that can do this. Back here. So with the chemical engineering department at UCSB, we've designed an artificial pancreas system, which is currently being used around the world to test these algorithms. So we have a sensor every 5 minutes. It brings a value into the laptop. And then the algorithms and the braining operations here tell the pump to do. And then we recycle this over and over and over and over. We've done hundreds of clinical trials on this, and our next step is to take it from the clinic to move it to the outpatient and finally to get approval. A wise man, Arthur Weasley, once said, "Never trust anything that can think for itself if you can't see where it keeps its brain." And I think this is a very wise quote, because we're trusting ourselves to things that we don't really understand. And as a designer of technology, I think what we need to do is really have an unspoken agreement with the users that we're going to do our best job to make them work as well as we can. There will be problems. And for the user to be trusting that the people that are actually making this technology have that in mind. This is Tommy. He was one of our interns last year. Here's the insulin pump. There's the sensor. Here's the receiver. And here's where the brain of the operation is. It could be on a tablet, a phone. Eventually, it will be back on the insulin pump itself. These are just backup devices over here. This is where he ate. Or we fed him. Maybe that might be more appropriate. So I'm just going to talk about some innovations that we've made and then go on from there. This is a tracing from Bruce Buckingham at Stanford. This is a camper, a young woman who had low blood sugar, so anything down here is low. Alarm, 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 alarm. She can't respond to the alarm because she's low. She's confused. She ended up having a seizure, recovered well, and everything was fine. At the time, we were really the only ones in the world that can take that information off the patient. and really send it anywhere in the world. So we developed a predictive alarm. So we don't wait until she's low. We say, we predict that you're going to go low, do something that's proactive. And additionally, well, getting to that, we can send this information anywhere. So this is from a study. The patient was actually on the other side of the wall, but this took us a lot of work to get approval from FDA to get just to be able to send a text message from our system for safety. So talking about FDA, this is the only journal copy I've got of this journal. And one day, while I was arguing with the FDA, it showed up in the mail. I just thought it was a great image. They make things costlier. They make things more frustrating. They make things take more time. But they also really help craft the design and sculpt the design. And their main focus is safety. Who's using it, what environment, and how can you make it as safe as possible? They don't expect it to be zero risk. They just expect it to be as safe as possible. Back to Dr. Evil. Every designer or design team needs an overlord. When we're working with complex things like this, it takes a lot of work and a lot of small pieces. And there's specialists that can come in and do that one thing really well. But if there's not someone who's overseeing everything, putting everything together, you end up with something like the Tower of Babel. I'm going to briefly talk about trust, which I think seems like such a concrete thing until it's not, until you've been betrayed by either a person or by a device. This is an unfortunate gentleman experienced something which is aptly named, but not something anybody wants. This gentleman actually had dead in bed syndrome. So here's wearing a tracing that you would put on and go to the doctor and look at the data later. Unfortunately, there's no inherent alarms built into the system, so there's not much in the way of safety. He was having a lot of low blood sugars, and so they put this device on to see if they can figure out where it was. He ended up taking a lot of insulin late at night for a correction. Blood sugar went low, ended up having a cardiac arrhythmia, and didn't wake up the next morning. More on the Dr. Evil. This gentleman actually figured out how to hack into insulin pumps. So there's an insulin pump this mannequin's wearing. And from across the room, he can dose someone's insulin without them knowing it. Fortunately, he's not Dr. Evil. He's a nice guy, actually, that the FDA and the manufacturers know so they can fix the problem. Fuchsia said a lot of things. He said if you wanted to rule the people, you needed weapons, food, and trust. But never give up trust, because trust is more important than life. These are just some of our patients. These are 5 patients and our collaborators from the University of Virginia as we're moving this technology from in the clinic to outside. Lastly, I just want to finish up with a personal story. This is one of our other physicians, this is Dr. Castorino, and she helped one of our patients have a normal pregnancy, and this is her son. And he is gnawing on his mom's insulin pump. She has type 1 diabetes. This is him a year and a half later, and unbeknownst to anyone in this picture or the photographer, he had already had signs and symptoms of type 1 diabetes. Within a week or two of this picture, which is about 2 months ago, he was diagnosed with type 1 diabetes. And this is him. I just love his mom sends me these pictures all the time. He's such a cute kid. This is him at Halloween. Halloween is a very difficult holiday for people with type 1 diabetes because you're going around collecting sugar, and sugar is toxic to these. So he actually went out, collected candy, and his parents exchanged a fire truck for all his candy. It actually wasn't this fire truck, a smaller fire truck. But he's doing well, and his life is going to be interfaced with technology, hopefully our artificial pancreas that we're creating. And I just want to finish up with 2 slides. His mom sent me this picture, and the first thing I thought was trust. This is the day that his insulin pump arrived, and he couldn't wait to use it, and couldn't wait to interact with it, because this will help him for the rest of his life. And hopefully, one day soon, we'll be able to provide him with an artificial pancreas. Thank you very much.